Hello students, welcome to LearnGuru Classes. So today we are going to start with a new topic, that is irrational numbers. So by the name irrational, you can predict that something or some numbers that are not rational are called as irrational numbers. To be more specific, the numbers that cannot be expressed in the form of a ratio is called an irrational number. So how do you express a ratio? We express a ratio in the form of P by Q. Okay, so the numbers that cannot be expressed in the form of P by Q are called as irrational numbers. So there are various examples of irrational numbers, but before giving you the example of irrational number, let us know what are the types of irrational numbers or how can you identify any irrational number. These are the ways by which we can identify any irrational number or the types of irrational number. So first one is non-terminating and non-repeating decimal expansion can also be termed as an irrational number. Why is it so? Please notice this is an example of a non-terminating and non-repeating decimal expansion. By non-terminating, we already know that when we do the division, the remainder never comes to be 0 and you get an infinite quotient, that is you get an infinite number of numbers after the decimal point. So this is how our non-terminating decimal looks like. But what is non-repeating? Non-repeating is, if you see this particular example where after the decimal point the entire number or the sequence of number consists of 3 digits 0, 2, 3, but if you see 0, 2, 3, then again 0, 0, 2, 3, 0, 0, 2, 2 means what? Uniformity of the repetition of the digits are not being maintained, right? Repetition occurs but not in a sequential manner or not in a uniform way. So this is an example of a non-terminating and non-repeating decimal expansion. Whereas come to this particular example 3.4798542668, so you cannot see any repetition of the digits or a non-uniformity of the repetition of the digits are being maintained, okay, and it will continue till infinity. So this is also an example of non-terminating and non-repeating decimal expansion. So if you encounter this type of numbers, so you can just directly say that this is an example of an irrational number or this particular expression is an example of irrational number. Okay, now come to the second point, square root or cube root of some positive integers. So square root, that is examples such as root over 2, root over 3, root over 5, root over 7, root over 11 are examples of square root of any number of some positive integers, of some positive and or cube root of some positive integers. Why I am telling you some, I will come later. But for now, suppose root 2. You will ask me, how can you say root 2 is an irrational number? So if you find out the square root of 2, the corresponding decimal expansion will be something 1.41421338, something like this. So it takes the shape of a non-terminating and non-repeating decimal expansion, which again we have already defined it as an irrational number. Similarly, the case of 3, root over 3, root over 5, root over 7, root over 11, even cube root of 2, cube root of 3, all these are examples of irrational numbers. Okay, now why I am telling you positive integers? Okay, because if root 2 means the number that is under the root should be a positive integer. If we write minus 2, if we replace minus 2 by square, within that if we give the square root, so that basically represents a complex number or an imaginary number that you are not going to study now, you will be studying in your higher classes. Okay, so as square root or cube root of some positive integers are irrational numbers, because if you see the decimal expansion of these numbers, you will see that they are following the trend of non-repeating and non-terminating and non-repeating decimal expansion. But there are some exceptions, like exceptions I will write here. Exceptions are, suppose I cannot write root over 4, or I cannot call root over 4 as an irrational number. Why is it so? Because root over 4 I can write it as 2 square, isn't it, and within root. So if we will replace the root with half, because the value of root, if you remove it, directly becomes to the power of some number to the power of half. These things you probably know. So this and this gets cancelled, so you are left with 2. So 2 can be replaced, can be called as a rational number, because we can represent it in the form of p by q. So we cannot say root over 4 is an irrational number. Similarly, we cannot write cube root of 8. Suppose cube root of 8 as a rational number is an irrational number, because cube root of 8 we can write 2 to the power of 3. So this, if you remove this cube root, you will get 3 into 1 by 3. You can just cancel it. So it will become again 2 by 1, which is a rational number. So cube root of 8 is also is not an irrational number, but it is a rational number. So to generalize it, any perfect square, how do you represent? What are the examples of perfect square? Perfect square like 4, then 9, then 16, 25, 36. All these are examples of perfect squares. So a perfect square under the root are not irrational numbers. As well as perfect cubes like 8, 27. Okay, so these are examples of perfect cube. So any perfect cube, if you keep it under cube root, so these are also called as rational numbers. So these are exceptions. Perfect squares and perfect cubes under the square root or cube root respectively are not termed as an irrational number. So we have got two examples. One is your non-terminating and non-repeating decimal expansion are irrational numbers, and square root or cube root of some positive integers are also irrational numbers. Okay, so again, if I tell you, is 1 root over 1 an irrational number? We cannot say root over 1 an irrational number, because root over 1 we can write it as 1 square. So 1 square, this gets cancelled, the 1 by 1. So you are getting a rational number out of it. So root over 1 is not not an irrational number, but it is a rational number. Okay. Now I am going to tell you about an interesting example of irrational number, that is pi. Okay, so pi, you have heard of the name pi and you have used extensively the value of pi in your lower mathematics class. Okay, even now also you are using the value of pi. Now what is pi? Before coming into why pi is an irrational number, let us know what is a pi. So pi is basically the ratio of circumference by diameter. That is, circumference is the length of around the circle, and diameter is the line that is joining the two ends of the circle, which is dividing the circle into two equal parts, is called the diameter of a circle. So everybody knows about this definition. So pi is what? Pi is circumference by diameter. Okay. Now pi, if you calculate, if you have the value of circumference and diameter, you will see that pi is an example of a non-terminating and non-repeating decimal expansion. So this is the value of pi, 3.1415926535897, and it will continue till the end. So this is an example. This resembles a non-terminating and non-repeating decimal expansion. Okay, so from this value we can say that pi is an irrational number. But again, you may not agree with me, you know. Why? Because till now you have studied that while solving numericals, you have studied that pi can be replaced with the value 3.14, or you can give it as 22/7. So if I consider this 22/7, so 22/7 is a fraction, isn't it? So fraction is an example of a rational number because you can represent the fraction in the form of p/q. But why am I calling it as an irrational number? It resembles all the characteristics of a rational number. But pi is basically an irrational number because these values 3.14 and 22/7 is just an approximate value of pi. This is not the exact value of pi. Why you have taken approximate value? Because suppose you are asked to find out the circumference of the circle. So circumference of the circle, we can write it as twice pi r or pi into d. So d, the diameter value also we know, and we pi value from here we can calculate. If I use this value 3.1415926 into, suppose the diameter is 20 centimeters, suppose. So you just imagine what will your calculation look like. Your calculation will become very much complicated and it will consume your time. So in spite of that, if we try to reduce the terms and make it more concise, and if we can represent this concise value in the form of a fraction, then our calculations will become much easier, isn't it? So this is the beauty of pi. All the things that you are using, so these are the approximate values of pi, not the actual value of pi. The actual value of pi is basically a non-terminating and non-repeating decimal expansion. So henceforth you will say that you will identify pi as an irrational number. Okay, now so you have studied that any non-terminating, non-repeating decimal expansion or a square root of any number, cube root of a number of some positive numbers other than perfect square under the square root or perfect cube under the cube root are irrational numbers. Perfect square under the square root and perfect cube under the cube root are termed as rational numbers. This also I have shown you. So these are the two possible ways of identifying an irrational number, and of course we have pi if it is asked in the question, and if somebody asks you what type of number is pi, rational or irrational, so now you will tell that, you will answer that pi is an irrational number. Okay, so now we have identified what are irrational numbers. So next class we will study what are the properties of irrational numbers. Like if we add two irrational numbers, what will be the outcome? If you add one irrational number and one rational number, what will be the outcome? So these things we are going to study in the next class. That time your idea about irrational numbers will be more clear. Okay, so I am ending the class here. If you find this video helpful, please subscribe to LearnGuru Classes, like and share it with your friends, family and relatives. So thank you so much. Bye bye.